Now that both sides of the front half of the fuselage have been tack welded together, it's time to concentrate on the aft section, and the two longerons for one side are laid out on the plan right now. Now it's time to cut and fit the vertical and diagonal members that go in between. So we'll get started on that right away. Here's the drawing of what the main carry-through spar for the wing is supposed to look like. And here's the full-scale 3D rendering in metal after all the welding has been done. And this was constructed exactly the same way as we constructed the sides, cutting and shaping the pieces, same methods that were used before, and then it was all welded up. Now the next step is to take this and stand it up into a vertical position and begin to connect the fore and aft sides to the carry-through spar and fabricate all the cross members and diagonals that will be used to connect the two sides together. Okay, now comes the hard part. We've got the wing carry-through spar jigged in an upright vertical position, and the two fuselage sides, the four sides of the fuselage, are jigged with the Station 3 temporary cross members in place, and everything's secured to the table. And now it's time to bend the station forward of the Station 3 sides into about a 15-degree angle, and that will give us the final shape of the front section of the fuselage. So we're all set up here with some rigging and a torch, and it's time to give it a go. This is my first time having to bend 4130 steel tubing. The recommended method used to bend 4130 steel tubing is to heat the inside of the bend to a dull red while applying a constant pressure, allowing the tubing to slightly kink as the tube bends. You don't want to heat the outside of the tubing, as that allows the tubing to stretch, which will weaken it. Okay, looks like just about the right position. Alright, now for the other side. Okay, that's it. Okay, as you can see, we've accomplished quite a bit since the two sides were bent together. All the pieces that go in between the cross members and the diagonals have been cut and fitted and put into place. We started with station 1, upper and lower cross members. Those were cut and fitted. And then we found we had to do some clamping and jigging to straighten up the sides so that they were perpendicular and parallel. They tend to get a little bit twisted when they're tack welded together, so they have to be trued up, and that's done with some straps and clamps and some wood blocks on the table, and that helps to true everything up. Once the station 1 cross members are put in place, then the diagonals were cut and fitted, and the nose gear tube was clamped in place in order to make sure that the diagonals fit into here properly. The upper and lower station 2 cross members were cut and fitted, as well as station 3 cross member that was in there when we did the weld, or did the bending. And then the diagonals were cut and fitted for the lower and the upper station 1 to station 2 diagonals, and the lower station 2 to station 3 and the lower station 3 to station 4 diagonals were cut and fitted, and they're all being held in place just by friction right now. There hasn't been any welding. The support diagonals for from upper to lower on station 3 have also been cut and fitted. And we're not going to weld any of this together yet. What we're going to do is take this all apart, because we're working down in the cellar now. We'd never get it out the door if it was all welded together. Take it all apart, and the next section will be the tail section. So we'll build up the tail section in the same manner and cut and fit all the pieces, and then disassemble that and bring everything out into the garage, reassemble this table out in the garage where it will be large enough space to put it all together, and then we'll start the welding. So the next portion of this will be cutting and fitting all the pieces for the tail section. We'll get started on that next. As you've just seen, the cutoff saw is very useful for cutting pieces to length. Once they've been cut to length, then they have to be fitted to mate with the other pieces. The next essential tool necessary to do this is the drill press. This has many uses depending on what tools you fit it with. Right now it's outfitted with a 5/8 inch hole saw. You can get an arbor that will take many different hole saw blades, and you'll need various sizes for this project. This one's set up with a 5/8 inch hole saw, and now we'll go ahead and show you how to cut or shape a piece to fit another piece using the hole saw. This is good for any angles from 90-degree fit down to about 60 degrees. Once you get past that, you need another method of shaping, and we'll show you that in just a minute. Okay. Now, if you clean this up a little bit, you'll see you get a nice fit with the proper size tubing. If you use the right size hole saw, this gives you a nice clean weld fit. When you set this up, you need to set the drill to a very slow speed, and you have to work very slowly with it so that it doesn't bind. Now, the next thing we're going to do is put a different tool in here and show you how to shape pieces a little bit more closely. Another way of fitting tubing even more precisely is by use of a rotary file. The drill press has got a rotary file in its 5/8 diameter. These come in various sizes depending on what size tubing you want to fit to. We're using a 5/8 piece of tubing that's going to fit to another 5/8 piece of tubing. So I'm going to go ahead and cut it to fit with a rotary file. And this can be done at any angle from 90 degrees down to about a 45-degree angle. And it's very easy to do. You need a cross-slide vise, which allows you to move the piece in either direction to get a good fit. And I'll go ahead and show you how that's done now. Into the rotary file, and it files away the metal that you need. Okay, this allows you to get a much more precise fit. And this angle is about 75 degrees, so this will give you a 75-degree angle between the two pieces. And all that's necessary now is to deburr this, and it will be all ready as a cross member. These rotary files can also be used in a portable drill, hand drill, to get smaller angles than the 45 degrees. If you need a really tight angle down to about 15 degrees or so, you can put one of these rotary files in the hand drill and clamp the piece in a vise and vary the angle to anything you need it to be. It's not quite as precise that way, but you can't go too much of an angle using the table on the drill press. Whenever you need to join two pieces of tubing at anywhere between 15 degrees and 45 degrees or so, as when you're joining diagonals between two longerons or a couple of verticals. There's a two-step process that I use. Use the bench sander with a 1-inch vertical sanding belt with a very coarse grit as the first step, and that gives the a rough cut of the dimension that you need. Alright, that takes away a lot of the material right away. As you can see, you got a pretty good angle there. Then if you want a better fit, the next step is to put this in a vise, and with a portable power drill with a rotary file on it, you can scoop out enough of this tubing to make a really nice tight weld fit. And you can get just about any angle you want with this, down to about 10 degrees or so without any problem. Now with the piece mounted in the vise that I just ground down, I'll use the portable drill with a rotary file in it to fit this so it'll fit better with the other piece. And I will try it for fit. Okay, much better. Now you got a nice tight fit there, all ready for welding.